Hello again and welcome to another GCSE Computer Science Theory video. This video is going to be on Unit 1, Bubble and Merge Sorting Algorithms. So let's get started on a bubble sorting algorithm first. And for this example, like with my others, I'm going to copy this into, surprise, surprise, Microsoft Paint. And I'm going to use this to try and illustrate how this algorithm works. Let me delete this off the end, just to keep things nice and simple. Alright then, so let's say we have a list and I'm using integers. This will work with strings or letters or characters, but I'm going to keep it with numbers just to keep things simple. Now a bubble sort, it starts off by looking at two comparisons, two at a time, and it gradually makes its way through the list doing swaps. And I will illustrate that for you. So 6 and 7. Are these in order? Yes, they are. So they're fine. They don't need to swap. 7 and 4. What about these? These need to be swapped. Yes, they do. So I'm going to take 7 out there and swap them over. There we have it. What about 7 and 1? Do these need swapping? Yes, they do. Okay. What about 7 and 8? Nope. 4 and 8. They need swapping. And what about these two? Do these need swapping? Yes, they do. And what about these two? Yes, they do. And there you have it. A sorted list. No, wait, it's not sorted yet. I just want you to have to think about something. How many times do we need to repeat this method before the list is finally sorted? Just pause this video and have a think about it, and unpause when you're ready to continue. Okay, because we've got 8 items in our list, we're going to have to repeat this step 8 different times. So we're going to have to do all of those sorts 8 times, or the same length as the list. So if you had 100 items in your list, you would have to do 100 iterations of this. I'm going to talk you through just the next layer of this sort, which is exactly the same thing. I'm just going to repeat myself to make sure that you understand. And I'm going to do the rest automatically for you so you don't have to sit through and watch me fumble about with Paint for too long. So we're just going to do one more step together and then I'll show you the completed version. Okay, so 6 and 4, do these need to be swapped? Yes, they do. Okay, what about 6 and 1? Do these need to be swapped? Yes, they do. And what about 6 and 7? Do they need to be swapped? No. What about 7 and 4? Yes. What about 7 and 3? Yes, they do. And what about 7 and 1? Yes, they do. And finally 7 and 8. Do they need swapping? No, they do not. Okay, so I've completed most of these already for you to shorten down this video a little bit. And I'll just do the last 2 steps for you. So, do these need swapping? No, they don't. Do these need swapping? Yes, they do. And you'll notice that our list is already sorted at this point. However, our algorithm is not sophisticated enough to know when to stop, so we carry on going. Are these sorted? Nope. Do these need swapping? Nope. Do these? Nope. Check these, and then check these. And then finally, we do the 8th layer, which is completely unnecessary, I know, but again, our algorithm isn't sophisticated enough to know when to stop. These need checking? Nope. These, this, check that, check these, and check that. Our algorithm is definitely sorted. but it just isn't smart enough to know when to stop. And you'll notice a pattern occurring here. With this first attempt, the biggest number is on the right. With our second attempts, the two biggest numbers are now on the right, and so on. And that just keeps on growing as we get along. So there are several inefficiencies in this algorithm. We get into situations where we sort for no reason, even though we've already sorted, and we carry on comparing these numbers on the right, even though they are already sorted. But later on in this video, we'll talk about how we can optimize these algorithms. Okay, so next up is the merge sorting algorithm, and I just ask for your patience in particular with this algorithm because the first step is going to seem completely pointless to you and you're going to wonder what is the point in it. My advice is don't worry about it at GCSE level. There is a reason for why we're going to do this first step, but it won't become apparent until well into your A levels. So first of all, with the merge sorting algorithm, we need to take our list and we need to split it in half and make two separate lists, like so. Now we're going to split these in half again, so we're ending up with 4 separate lists. And then we're going to split them in half again, making 8 separate lists. And you're probably thinking, what is the point in having lots of separate little lists that just have one item in there? It does seem pointless, but just trust me on this. This is part of the algorithm. Once you've got your 8 separate lists, we're going to start merging them back together again. And I'm going to use Microsoft Paint to help me explain this. Alrighty then, so we've got our list. What we're going to do first is take a look at just 2 items on the left. And we're going to decide which is the smallest of those 2. 6 is smallest, isn't it? So we'll put in 6 first, followed by 7. Next, we're going to look at the next 2 lists. And we're going to think which is the smallest. Well, it's 1 followed by 4. And then looking at the next 2 lists, which is smaller, 4 and 8. And which is smaller here, it is 1 followed by 3. Okay, there you have it. There is our very partially sorted list. We're going to do the same operation again, but it's going to get a little bit more complicated now that our lists contain more than 1 item. So to start off with, we're going to look at 6 and 1. We're just going to compare those two. Which is smaller? 1 is smaller. So we're going to put 1 in there, cross it out, and move over to 4. Now we're going to compare 6 with 4. Which is smaller? 4 is smaller. So we're going to cross that out. Now 6 is left. We've got nothing to compare it with, so we just write it in. Now we've only got 7 left. There's nothing to compare it with, so we just write it in like that. Let's try that again on this side. Let's compare 4 with 1 and shift that over. Let's compare 4 with 3. 3 is smaller. And we haven't got 4 to compare anything with, so let's just write that in. And we haven't got anything to compare 8 with, so just write that in as well. So there we have it, a very almost sorted list. So we've got 2 separate lists. Have you noticed that both of these lists are sorted? Not together, but individually these 2 lists are sorted. So next we're going to merge these 2 lists, and this is where it's going to get very complex. So let's look at 1 and 1. So these are both the same, so it doesn't matter which one we put in first. Now let's compare 1 with 4, so 1 goes in first. Let's compare 4 with 3. 4 with 4, well again, they're the same, so it doesn't matter which one goes in first, but given we went to the left last time, we should stay consistent. Now let's compare 4 with 6, well 4 is smaller. And let's compare 6 with 8. 6 is smaller. And let's compare 7 with 8. 7 is smaller. And we don't have anything to compare 8 with, so we just write it in. And there we have it, a fully sorted list. And in terms of the exam, they could give you this top row and they could ask you to fill in the blanks. There's just one more slide to show you before we go. And it's just a comparison of a bubble sort and a merge sort at a glance. So a bubble sort is very easy to code, but it's incredibly slow. We can add some optimizations to the bubble sorting algorithm to make it faster, but it is still very, very slow. Even with optimizations, it is incredibly slow. A merge sort, however, is really, 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 really fast. It is the fastest sorting algorithm out there. However, it is incredibly difficult to code. In fact, if I gave the code to you at GCSE level, you would probably soil yourselves and go home crying. So I'm not even going to attempt to show it to any of my GCSE students. In fact, I know lots of A-level students who can't program this. I know many professional programmers who can't program a merge sort. That's how tough it is. Anyway, that's the end of this video.